I'm trying to get an idea. How many of you are at a clinic where either you are going digital or you're considering it? Is that something that you can raise your hands? Okay. How many are readers, physician readers, or okay? How many people already have digital systems? Okay, and have you all gotten NIOSH approvals? Anybody with NIOSH? Yes, several with NIOSH approvals. Great. Okay. Well, what I just, this is going to be a very practical talk, and what I'd like to do is be a little bit more relaxed than we often are, and just raise your hand, because if I don't address every issue that you're interested in, then I'm going to be missing the whole point here. So let me just start out by saying we've come a long way. Actually, it was about 100 years ago when X-ray started to be used to look at miners' lungs. This is an article from 1915 in the Public Health Bulletin, and they showed these. How many of you could read that X-ray? So we have come a long way. Analog radiography improved quite a bit, but now we have digital. And there were a lot of problems initially with analog, and those were worked out. Now we're in the same process with digital. What you're all talking about in this, I think, discussion is getting NIOSH approval. And I'd just like to sort of go around the circle. You have an imaging system, you have a quality assurance program, you have some way of getting images to the people who are going to do the interpretation. And when you have all this together, then you can document that you meet the NIOSH standard. And I think that it's really not a difficult challenge. It's one that most of you, probably all of you, are going to be able to do very easily. But we'll just go through and talk about each piece of this business. This is what they call a picture archiving and communication system. This is the PACS that we all know about. That is the way that we manage the image files from a digital system. There's, sometimes the X-ray equipment really doesn't look very different, but then we get either a direct connection from the receptor to a computer, or sometimes we have to go through a CR reader. Let me just ask you, how many, if you're digital, how many have a CR type system which has a cassette, and that you have to run the cassette through a cassette reader? A couple. How many have a direct system where there's no cassette, the receptor goes right into the computer? None. Okay. Well, yes, some do. I think have either or. Well, I think that the industry is moving away from the cassette-based systems. That was the initial. Implementation was a lot easier with a cassette, because you could just use your old X-ray equipment and just put the digital cassette in and then have it read and make an image file. It was less expensive, and probably a lot of implementation started at that point. The direct connection systems are more expensive, and that's one thing about any technology. It's the initial startup costs are going to be significant. They're much more than, a view box. $200 for a good view box? A digital imaging system, just the reading, is going to be much more. So what we'll just talk about, what the terms are. You're probably going to hear the term DICOM, which is the Digital Imaging and Communications in Medicine. It's called the DICOM standard. How many have heard that term? Okay. And like in any electronic image transfer, the systems have to be compatible. You can't send out an image and then the receptor not know what you're talking about. So the DICOM standard really is a standard for what the files look like and how you transfer them from one piece of the equipment to the next. And the manufacturers of equipment and the national electrical system manufacturers have all come up with what they call a DICOM standard, which allows the equipment to talk to each other. And that's, your equipment will have to meet that because everything that's manufactured has to meet it. But unfortunately, it's not as standard as you'd like to think. There are different implementations, and we're having problems. For example, some CR systems and DR or DX systems they don't give you the same image, so there has to be some additional software that you need to implement those. So let's just talk about the image acquisitions part of it. The X-ray generator is pretty much the same whether you're digital or analog. Then in a digital system, rather than having film, you have some digital imaging capture, which I mentioned can be either a cassette or a direct reading hardwired receptor that just sends the image back into the computer. With the CR cassette systems, you have to have the cassette read, and then that device sends a file to the computer. So in the end, you get an image file which has all of the data on the chest X-ray in a computer file. One thing that I have to point out is that some people have wanted to scan films into digital images, and this can be done. You can have a laser scanner that will give you a file, which is a DICOM compatible file, but that process is not as well standardized, and because of that, NIOSH does not accept this type of image. You can use it maybe for clinical purposes, and that's fine if you want to go back and compare, say, an X-ray, an older X-ray to a digital image. But you can't send that in as a NIOSH qualified image. Now, the Department of Labor will accept this as what they call other medical evidence. But you have to understand that there is a quality concern as to how that scanner was operated, the conditions of that scanner, and whether that image file really is adequate to visualize the pneumoconiosis. Now, you've all heard that NIOSH is updating its standards for the dust regulations that MSHA put out, and that the NIOSH specifications for both X-ray and spirometry and so on are in this new regulation that really just came out. But the good news is that the X-ray part of it has not changed, so you don't have to worry. If you have a NIOSH X-ray facility or you're trying to get approval, nothing new from this rule is going to affect that process. I would point out that NIOSH does have the specifications. It's not anything that most systems don't meet, but I would encourage you to look at the NIOSH guideline for the classification of digital radiographs, because it goes through what the imaging equipment, X-ray generator, and so on should be. And they're technical things, but it's all available on the NIOSH website through this document. So if you want to assure yourself that your system is satisfactory, then this is the place to go, as well as the rule which spells out what's required. So as I mentioned, with the new rule, there's really no need to change anything. The same process, which I'm going to go through here, is required. So that's the imaging system. And I think that most imaging systems that are purchased today are going to be adequate to meet the NIOSH standards. They have to have the right amount of pixels and the right grayscale and so on, but I think you're going to find that it won't be hard to meet that. The next thing, which is probably a little more difficult, but still something you will be doing, is the quality assurance. NIOSH has always had quality assurance issues. I mean, anytime you take X-ray, you have potential exposures, you have quality issues regarding the image resolution and so on. So this is nothing new, but it will be a little different with digital imaging. And what you're going to have is, and everyone does have this, you have a consultant when you first install the system that comes in and makes sure it's meeting specification, and you get a report. NIOSH will know then you'll need to keep a copy of that report and make sure that you have documented that the consulting physicist has evaluated both the X-ray beam and the resolution and so on of the digital imaging system, so that you have that. That's the acceptance tests. And then NIOSH also requires, and a lot of states do require, that you make sure that the system stays in calibration, and so you'll have an annual inspection. And you're going to want to, this is something that you may not have, but you're going to want to be sure. And NIOSH looks at and sends you reports on the quality of the images, but you're going to want to have some documentation that you have evaluated your image quality and that you find it satisfactory. So what I would suggest is that you keep, and I think it's required because if there is an audit, you will have to show that you have your initial acceptance test and that you have a quality assurance program in place, which, pretty much everybody is going to do because that's the nature of medical examinations of any technical type. So keep a file which is available in case there is an audit, which the regulation does permit NIOSH to audit the quality and ongoing safety of the system. The next thing that's really quite different, but and will require a little bit of additional technology, is the image file transfers. Because of security issues, accessing these image files is not straightforward, and a lot of PACS manufacturers make very good systems to prevent anyone from accessing these confidential medical image files. So transferring them is not always that easy. All of them will have some type of local storage and will be able to transfer within the PACS system. So your facility radiologist or whoever currently does your readings will have a way of getting into those image files and having a directory, picking the images that they will read and displaying them and so on, and then writing a report. What's new is this part, that you're going to have a system to transfer the images to NIOSH. And NIOSH has technical support people who will help you do this. There are two approaches, the secure internet transfer and the encrypted media transfer. Now, we all would favor the secure internet transfer. It's press a button, the image goes, and you're done, rather than having to cut a DVD or CD in specially encrypted software. You can't use your own software. It has to be federally approved software to do the encryption. So that's a little tricky to do that way. We encourage everyone to really try to use the secure internet transfer, and I'll tell you what that entails. It's not a big thing, but there are some procedures you have to go through. One thing I have to say is that the standard proprietary CD software that you use, that will not be satisfactory. Neither the quality of the image file nor the security is adequate for what the federal government is going to require. So you just can't burn a CD with using your standard CD software. That will not be satisfactory. So how do you do it? Well, there are really two levels. The first is just the simple security. The federal government requires security when any government-associated computer systems are accessed. And what's going to happen is when you transfer that file, you're going to transfer it to NIOSH, so you're accessing a government computer. To do that, you have to go through this secure access management system. It's not a big thing, but it is something that you have to do. And at least one person at each facility will be authorized to access the government computer, and you just have to go online, give that person's credentials. The credentials will be accepted, and then they will be the person who can use it. They'll have their own password and so on. And that is just to get into the NIOSH connection so that you can transfer the image, chest X-rays of the coal miner. And that person will go to the software site, the Secure Access Management Service, which is a federal website. CDC operates it. And I'm not going to go into the details of it because you're going to have to talk to the NIOSH technician, and they will tell you how to get your security access to this. You only have to do it once for each person who does it. You may want to have several people at your facility who do this. It's not a big thing, but it will have to be done. Once you get credentialed, or someone credentialed, then you have the actual image transfer software, which NIOSH is using a commercial product called PyCom Cloud. And it, uses the cloud. I don't know what that means exactly, but it goes into the internet, and then it goes to NIOSH. But it's always encrypted in a way that even if someone gets the data, there's nothing they can do with it. They can't reconstruct that image or find out anything about the individual. So it's a secure internet transfer for image files. And a lot of facilities use this. For example, if you have teleradiology or teleradiography, you have a reader somewhere, then they're going to use this type of transfer of image files to your radiologist so that they can look at it away from your facility. Now, what will happen with and I'd like to hear the folks who already have been through this. You have to install this PyCom software somewhere at your clinic, in one of the computers at your clinic that has access to the internet. And most everybody has this, so it shouldn't be a problem. And then once you have the security, then you can use the PyCom, and then you establish a PyCom account for your clinic. And there are two ways that you're going to probably do this. If you can get your clinic PACS unit to accept this software, and some of them just won't because they're too secure, then you will transfer from your PACS unit directly. But for a lot of people, that's just too big a barrier. The manufacturers of the PACS software, they just won't let you put any other software on their system. So then you have to transfer the file to another local computer, and then that computer will have the PyCom software on it, and it'll transfer it to NIOSH. Is that clear what I'm saying? And our technical guy will work with you to see if we can get your PACS unit to be able to do this directly. If not, then you're going to have to pick those files, transfer them to another local computer. This is what the PyCom cloud software is. You just like any software, you put your username and your password in, and then it'll give you a directory, and you'll just point to the files that you want to transfer to NIOSH, and you click transfer, and it'll send them up and then give you a success screen, and then that's basically it. Much easier than trying to use encryption software, which I'm not going to go into because it has a very high level of sophistication when you put it on a CD, because then anyone who gets that CD might be able to access it. So that's the image file transfer part of it. Now, interpretation and reports for digital facilities is a little bit different than, yes, good.
Dr. Petsonk, sorry. At what point is the image specified for a certain coal miner or identified so that NIOSH can tell who it's from? I mean, it's a little too hard for me to see from here. How does this identify it?
Does everybody hear his question? Every file on your PACS system, where is that? Okay, right up in here. Every file has all of the data about that individual. That file is a DICOM file. There are a whole bunch of what they call headers, which are fields that have information about when the image was taken, what the specifications were.
At this point, you don't have to add it at the
No.
Okay,
That
was my question.
that information stays with the DICOM file. It gets encrypted so that it can't be read except by the appropriate software. But all of the personal identifying information remains in that DICOM file.
Okay, thank you.
Any other questions at this point? Because that's kind of one of the biggest differences. And I wonder if anyone who has done this already, the two folks who already had done this left the room. They're successful. But I think, some people, clinics have a little bit of problem and may take a couple days for us to fully work out how the transfers go. But once you get the system working, it's very simple. It's just a click through, point to the files that you want to transfer, and upload them, and that's the end of it. Now, as far as reporting, every facility already has a qualified physician reading the images, and that is not going to change. If there is an urgent problem, that physician who sees pneumonia or cancer or whatever is going to directly report to the minor that there's a problem that they need to have an urgent concern about. The next report, that physician also has to submit a classification, just as we have in the past. However, this classification doesn't necessarily, it's focused more on the non-pneumoconiotic things because the local reader can either be an A or B reader, as we have in the past, but it's not required for a digital image because those images are all transferred to NIOSH and are going to be read by NIOSH B readers as well. So that's a little different because of the nature of films. NIOSH wanted that local reader to do the classification on the film and send that to NIOSH. Because the internet and digital images are transferred within seconds, the timeliness could be maintained without having to mail an image using a digital file. So there was no loss of timeliness by having only B readers classify. So the local physician can classify it, can be an A or B reader, as long as they're a qualified physician and have the, local, permission and capacity to read the films. They can continue to read them. They don't necessarily have to be an A or B reader. They do have to submit the classification form to NIOSH, which then goes, again, that would be, at the current time, those forms are mailed. At some point, they will be also transferred by the internet. And now, once you transfer the image to NIOSH, NIOSH will inform the local facility that they can remove that file. Now, why do we do that? Why is that? Because that is part of the original way of protecting the minors from having their medical data, inappropriately available. So, right from the beginning, there was concern that minors just won't trust the system and they won't be participating because they, are afraid of retaliation and so on. So, after NIOSH notifies your facility that they have received the X-ray image, then you can delete that from your PACS system file. As far as notification is concerned, NIOSH will send letters of their readers, the NIOSH national readers, to the minor, as well as if there's transfer rights, we'll notify MSHA of that. So once you have all that in place, then you're ready to do NIOSH approval. For each facility, we recommend that you email, phone, or mail NIOSH. Just say we're interested in X-ray approval. And then NIOSH will give you that security access credential so that you can start to do that process. And then once you have that, you can get the PICOM account, which is your way of transferring images to NIOSH, the software that does that. You fill out, complete a facility certification document, which is the same as has always been, except it has digital image information. And then you transfer both the sample images and that object. Most of you know the object. It's a step wedge, and you have to take an X-ray of that. Do you all know about that? Well, it's basically a way of testing the radiography system to make sure that the grayscales and the resolution is satisfactory. And every facility who does this, NIOSH sends them this object, they put it up and take an X-ray of it, and then send that X-ray to NIOSH so that the physicist can go through, and the NIOSH physicist, and make sure that the system is working the way it should. So that's the test object, and then you send 6 sample images to NIOSH using the upload that you have from your PICOM account. And then the NIOSH physician will go through, make sure that the quality is meeting satisfactory, and that's the end of it. This is the facility certification document. Not really, you can send in up to 2 units on one page. It just tells about the X-ray generator, the type of exposure, if you use a grid or an air gap, and the actual digital PAC system software and hardware that you're using, and who is doing it, the technicians or technologists who are doing the radiographs. And then after that is done, and you say, here's the what's called the object, test object. This is the current test object. I'm encouraging NIOSH to use a newer test object, but that's going to take some time. These are old things that need to be updated, I believe, because this is really designed for film rather than digital images. And then once you become approved, which after you complete all this, you will most certainly be approved. I don't think there's any facility that hasn't, after maybe one try, gotten approval. Sometimes they had to change some things, talk to their PACS manufacturer and change some settings and so on, but they were able to do it. And then you get listed on the NIOSH website, and when anyone, or particularly the mine operator, looks for regional X-ray facilities, then your facility will be listed both on the map and their contact information. And the other thing that you do as a facility, which we really encourage you to do, is to look for mine plans that are coming up in your area for reapproval, and contact the mine operator to say, yeah, we're approved, we're NIOSH, we're digital, we would like your business. And hopefully that'll stimulate them to send miners in your direction. So just I'm going to go through some of the guideline or useful references. This guideline, which I think is nice and gives you kind of what you need to become approved. The U.S. government printing office has this website where you can get the actual text of the regulations, and that's just basically to show you that the PDF of the regulations is there. So that's pretty much that process. And I would like, because there are some radiologists here, to talk a little bit about the classification end of it, because that also has changed a little bit. Like I say, a film box, just a view box is a simple device. NIOSH had to do a lot more specifying as to what type of image display you should use when you're actually classifying films. How many have a pocket computer? Probably half or more of you, or certainly a laptop. But you can get the image to display on that, but it's just not satisfactory. So there had to be standards for what type of display was a minimum for reading and classifying images. The other thing that really was important was because we have hard copies, it's really not the classification system was based on hard copies, and it's just not satisfactory to have a view box and look at a monitor. That is not an adequate way. Your eyes can't adjust to the differences in the images, and it's really very hard to compare what something looks like on a view box to directly looking at a image monitor, because they're very, very different. So the first thing that had to happen was the ILO had to issue digital standards for the radiographs so that the readers could compare side by side on a viewing system rather than half and half. And ILO has these. The DVDs are available on the ILO Publications website, so you can get those images and then display them. This is their product, and here is the digital image guidelines on the ILO website. If you need to purchase them, this is where you would get them. It had going digital had impacts for NIOSH, which are still being worked out. There's the NIOSH B reader examination, the joint NIOSH College of Radiology symposia, and then the exam. The teaching syllabus itself. So those were all aspects that had to change, and now NIOSH can. If a reader wants to take the examination in digital format, it's now possible. All of the old exam has been digitized, and you can use the NIOSH system. And I don't know, has anyone done that in the room? No. Well, coming down the road, you're going to be able to do that, and at some point, I would guess that they're going to drop the film examination, but that may be another 5 or 10 years before that's done. But there is now a digital examination. Yes?
So, for the B-readers taking this examination, how is the digital examination different from the plain film examination, other than the fact that one's on a computer and the other one's on display monitors?
At this time, the question is, how is a digital exam different from the film exam? And the answer is, at this time, there is no difference. It's the same set of images, and all of the standards are also digitized and available on a side-by-side monitor. So you go through the same process. The classification, instead of being put on paper, you click it into a computer monitor.
And pass rates identical?
Well, there probably isn't enough information to say that that's the case. Now, for NIOSH to be able to do this, they developed software so that they could have the examination and do the things that Dr. Sood is talking about. That is, display the images. One of the really important things is that the ILO standards cannot be changed. Now, most of you know that when you have a digital display, you can change the intensity of the light, you can change the contrast and other things, size and so on. But if you have standard images, you can't do that. So this software prevents you from changing the standard images, but you can do what you feel is best for the subject image or the unknown. And this software is available to anyone who wants it for a free download on the NIOSH website. It doesn't include the standard images, which are owned by the ILO, but it does allow you to easily upload the standard images into the software, and then you have a full system that you can use that has, you can display the ILO standard image, the unknown image, and you have a third screen, if a lot of PACS systems have, where you can show your classification form and just click through, and I'll show you that. So, for example, the NIOSH software will allow you to choose whatever standard image you want to compare to. So if you say click on the 33R, it will come up on your screen. So this is what it looks like. You have the standard image on one side, the unknown image here, and then over here you have your selection window, your directory, and I don't show it right here, but I'll show it in the next slides, your reporting form.
So, for that, RPAC software has to be able to talk to the NIOSH software so that you can import the film from RPAC software into the NIOSH software while you're viewing the film and comparing it with the standard. Isn't that very complex?
If you are going in Morgantown, if you do, or wherever NIOSH gives its exam, this will all be loaded on the system. So that's for the examination. If you're classifying on your system, there are two options. You can load the BViewer software onto your system, and it allows you to basically do all of these things. You can select the images, there'll be directories, and the selection of the standards. Some people have had a hard time doing that. Some people do half of it. That is, they use the BViewer to display the ILO images in their own PAC system to display the unknowns. And some have had to go to a separate, basically unplug your display from your PAC system, and you can do it that way. But it is a little bit, it is technically challenging, and people work with their local PAC systems to find a solution that works for them. But again, just to show you, this is the screen that it's a sequential screen showing image quality, parenchymal opacities, plural and other, and so on. So you basically will click on, and each screen will open a new window which allows you to classify. Here you can see just the standard form shows you the zones, the primary and secondary opacity, the zones, and the profusion, and if you have large opacities and so on. You click this, and it's nice because it won't let you make a mistake. If you forget something, it won't let you go on to the next page until you complete it. And this is what the current NIOSH test examination site looks like. You sit in a cubicle, you have two high-resolution monitors, and then the third monitor is your directory and recording monitor. So let me just stop there. Any questions about what I've gone through to this point? Okay. One thing, this is an ongoing process. ILO and NIOSH have digitized, that is, scanned in the images that were filmed before. But now NIOSH is in the process of collecting new images for an examination and for teaching purposes and research. But these are digitally acquired images. In other words, new, fully digital images, not scanned. But they need help because they only have a certain amount of these images from mainly coal miners, and they'd like to see a lot of other images. So if you have images that you think would be useful for examination purposes or so on, other research or teaching purposes, NIOSH is asking you to submit these to the chest image repository, which will then be used for developing future digital programs. So the submission process has been approved by the federal IRB. All the DICOM headers are stripped out, so there's no identification of the person whose image is submitted. So that makes it basically anonymized data, and that has been approved. So it's a very effective anonymization, but we would really encourage you to help NIOSH make the full, complete transition to digital so that when people are taking these exams, they're not looking at digitized images, they're actually looking at originally digitally acquired images, so that that's kind of a more realistic and modern approach. And NIOSH has a really good staff. That's Travis Markle. Anyone who goes digital will know Travis because he's the go-to person. He really knows. He's worked with many, many facilities and coming up with a solution that will work for your facility. Anita, you know, and there's a whole staff there who is waiting to help you make this transition. So I'm going to stop there, and I hope that good. Thank you.
On the database that you keep at NIOSH, that they keep at NIOSH, do they track who the B reader is and what their reading was?
Yes, absolutely.
Do they run a statistical analysis to find how many B readers are outside of, say, through standard deviation from an average of B readers or something like that?
Well, NIOSH uses only about 10 readers on average who are reading for them.
Now, this is just for mine.
Right. In other words, classification is done outside of the NIOSH health surveillance program for underground or now surface coal miners are not stored at NIOSH. So, for example, DOL readings are not available to NIOSH.
Could they be paid?
Well, that's a question that I think the Department of Labor has to decide, and that's something that's an ongoing issue. I know what you're alluding to is, how do you recognize readers who are maybe out of calibration is what I like to call them. Yeah.
Maybe unreliable.
Yeah.
So Lee, at some point in time, I think 2 years ago, you mentioned that all DOL X-rays are sent to NIOSH and they get an independent BD. Is that not true?
Not DOL X-rays, no.
So I misunderstood.
Yeah, only NIOSH does readings of all coal miner currently working miners who are under the federal mandated health surveillance program. They also have research readings, but aside from that, NIOSH does not automatically get any other B readings.
The B reader certification itself, how long, once a reader gets certified, how long is that? 4 years?
4 years at this time. Mm-hmm.
So it's like getting your driver's license renewed every 4 years. The B reader has to come in.
They have to come to either Morgantown or to one of the symposia by the American College of Radiology and take the exam again. Now, the re-examination is shorter. It's about a little less than half of the full exam, which is a 6-hour exam. The re-examination is a 3-hour exam. But it's still a major burden, yeah.
Unlike the driver's license that most people get, the exam has only about a 50% pass rate.
Right. The initial exam has, throughout history, only about half of the physicians who take it will pass it. It's very difficult, really is.
One of the toughest exams in history.
And this is because this is really a hard thing to do. And that's why honest people can disagree, particularly at the low end of what's normal and what's not normal. And I think that, there's always going to be disagreement. The hope is that by having an exam, obviously if 50% of the people fail the exam, that means if they were doing readings, they probably weren't going to be too reliable. So you at least eliminate, it's like, you're not going to drive into a bridge abutment, but you still might not be a great driver. You know what I'm saying? So...
And NIOSH does publish the list of certified B readers, like the yearly.
It's actually updated every examination, which occurs once a month. Then if someone, when they pass that exam, they're placed on, and if they don't, then they're taken off.
So the number of B readers in every state been going down. With the digitization, do you expect that figure to fall further?
Did everyone hear the question? The number of B readers is going down. That's definitely true, and it's probably for a variety of reasons. And do you think digital imaging will improve that? I'm not so sure. I feel, the equipment is very expensive. These types of monitors are about $10,000 each. So if you want to set up a 2-image system, which is the minimum, you need $20,000 cash outlay, plus the computer, which is a couple $1,000s. So, I think that for the average guy who used to be able to pay $200 and get a couple good view boxes and become a reader, private reader, that was not a big barrier. I think this is a much bigger barrier. And I'm not sure which way it's going to go. It may be, I think, that especially because we have internet transfers, there are going to be fewer readers, they're going to do a lot more readings, and a lot of readings will be done away from where the miners are. In the past, it was a physical thing. If you didn't get it read right at the facility, you had to wait till it was mailed someplace else.
I think the non-radiology readers are unlikely to find
A system.
Putting so much cash outlay worth it to them.
Well, we're hopeful that the PACS manufacturers, knowing now that this is an application, will basically, if they want to use the NIOSH software, it's public software, they can just add that as a module to their PACS system, and it would cost them virtually nothing just to be able to make the software compatible. So I think we're hopeful that the PACS manufacturers will basically start to include this as an option so that every local radiology facility will also have that capacity.
Okay, thank you, Dr. Petsonk.
Well, thank you. Thanks.